All right, next let's do a cube root function. So graph f of x equals the cube root of x. Well, when you're taking the cube root of something, you could take the cube root of a negative number, 0, and a positive number. And because of that reason, our domain is all real numbers. And the numbers that we get, we're going to get negative, 0, and positive. Our range is all real numbers as well. All right, let's make an XY table. And I'm going to start in the middle here. I'm going to start with 0. And the cube root of 0 is 0. Okay, let's move on to 1. I chose 1 because the cube root of 1 is 1. And the next perfect cube is 8. That's a big gap, so I'm going to write 8 over here. So the cube root of 8 is 2, because 2 times 2 times 2 is 8. And let's go ahead and graph those points. So I have 0, 0, 1, 1, 8, 2. And that's a big gap I have from 1 to 8. So maybe pick another number, maybe 4. And you'll need a calculator for this. So the cube root of 4 is approximately, type it into the calculator. You could also do 4 to the 1/3 power, and you get approximately 1.6. All right, so that's a good point to graph as well. Okay, next, let's substitute some negative numbers. All right, negative 1. Cube root of negative 1 is negative 1. Cube root of negative 4, well, it's just going to be negative 1.6. And negative 8 is a good number as well. And now negative 2 times negative 2 times negative 2 is negative 8. So that's the reason. Okay, plot those points. I have negative 4, negative 1.6. And I have negative 8, negative 2. All right, you notice that there are 3 points that are in a row. These 3 right here. Now don't connect them like that. Just showing you. The way they really look is when you connect them, it looks like a little bit like an S, but it's almost vertical near the middle. So I'm going to try to do this right here. Something like that. Okay, I did it better in the negative side. And then once you make that part of the graph, extend it to graph the rest. Okay, there it is. Okay, and there's the graph of the parent cube root function. Let's use what we just did and graph g of x equals negative 2 times the cube root of x. So here's the work we just did, and we can use it to get the rest of the values. Just like before, the domain is all real numbers because we're taking the cube root, and the range, we're still going to get negative numbers, 0, and positive. All right, so I'm going to extend this, and now we have g of x. And because negative 2 is being multiplied by what we had previously, which was f of x, I can just take the f of x values and multiply them by negative 2, and that will give me the g of x values. So let's do that. we have -2 times -2, that gives us +4. -1.6 times -2 is 3.2. -1 times -2 is 2. And go ahead and finish up the rest. Now we can graph those points. Once you have the points graphed, go ahead and connect it. I would do the 3 points in the middle first. So they look like that. And then just continue that on the left side. Okay, there we go. There's the graph. Graph y equals cube root of x plus 1 plus 5, then state the domain and range. Well, the domain and range part is easy, because when you take cube root, you can substitute any number, any real number, and the graph stretches in both directions. So the range is also all real numbers. All right, first thing, let's identify the a, h, and k values. Don't see an a, so I'll leave it blank for now. H is -1 and k is 5. Okay, there it is. A is actually 1 because you have a 1 times that cube root. I will erase that one though, but if you want to put it there, go ahead and do that. All right, next, let's make that XY table. In fact, before that, what's our starting point? It is -1, 5. And you can go ahead and graph that. -1, 5. Okay, next, now I'll make the table. So we have X, we have Y, and here are the numbers I recommend substituting. Well, let's start with -1 first. So I know when I substitute -1, I'm going to get 5. Next, it's usually a good idea to go 1x to the left and 1x to the right, especially when you're doing cube root. So -1 plus 1 is 0, and the other direction is -2. All right. Okay, substitute those values and see what you get. You get 4 and 6. And you'll notice that there's a pattern here, that whenever you have the starting point, you could quickly get the next two values by adding a and subtracting a. So go ahead and graph those. Now I need some more values. You could pick whatever you want. I'm going to go with 3. Just to spread out the points a little bit. So when I substitute 3, I have the cube root of 1 plus, oops, sorry, that's 3 plus 1, and then plus 5. So the cube root of 4, I know from before, is 1.6. And then when I add the 5, I get 6.6. And the other point I'm going to substitute is -5, because it gives me that -5 plus 1 is -4. The cube root of -4 is -1.6. So whenever possible, try to reuse the same, cube roots. In other words, like cube root of 4, cube root of negative 4. It makes it much easier. Add the 5 and you get 3.4. So I'm going to go ahead and graph that. And now you're ready to connect them. So the blue lines are in a row. Watch me do it first if you're not sure, or check a graph on the computer. But it's almost vertical at the starting point. If you want, you can make a line with a very large slope, and then it goes off from that. And try that second part again. And there's the graph.